Excuse me. Welcome back. Unit 9, Lesson 7, Geometry, Surface Area of Nets. It's going to be an interesting lesson here. You're certainly going to need your calculator here, and we're going to get into this thing. So let me go ahead and get set up here on my end, and we'll get rocking and rolling here, and I'll be checking back and forth. So I will. Anyway, okay, so we found out that a net was really a two-dimensional flat object of a three-dimensional figure. So let's take a look at it. Total surface area is the covering of the areas of all faces, including the bases, right? Within a net, there can be congruent, which means equal, figures which are the same size and shape. So let's take a look at these nets down here a little bit. And when we do, you're going to see that, all right, and I'm going to label these a little bit differently, but certainly I'm going to say this is congruent to that. This, and this are all congruent. Okay, so this triangular prism is kind of unique because we can find the area of this, double it, find the area of this, and triple it. Let's take a look at the next one. Okay, so the next one is a rectangular prism, and we know what? That this and this are equal. Okay, the top and the bottom are equal, and then the front and really the back are equal. Now, the last one here is a triangular pyramid. And you'll notice that it's an equilateral triangle, which means each side is congruent. So guess what? Everything is equal here. And that's why I'm just kind of coloring it in all of the same lines. Okay. All right. Well, let's go ahead and get into this and see if we can find some surface area of this thing. There's a lot of different ways to do it, and whatever way works for you is great. But I know when I look at this deal here, I know that this and this is equal. Okay, so essentially, I'm going to find the area of this. I'm going to find the area of one of those. All right, and then I'm going to find the area of, all right, I guess I shouldn't use an X there. I would find the area of this, and this is the same. All right, so let's start with this. Shape 1 is going to be these two. It's going to be 6 times 8. Formula is area is base times height. 6 times 8 is 48. And I'll label it at the end. Shape 2 is going to be my x's, which is going to be 15 times 8. Okay, and that's also area is base times height. It's 15 times 8. 15 times 8 is 120. Okay, and this is just some mental math here. And then finally, shape 3 is our circles, right? And we know that what? What's our size here? So we know that we need this and this, right? This and this. So this is 15, okay? And I would transpose that 6 over. So it's 15 times 6. But our formula, again, is base times height, and 15 times 6, all right, is 90. Now, these are the areas just for one of these. What I'm going to do is add all of these together, and then I'm going to double it. So watch what I do. Okay, I'm going to take 48, hopefully you can see that, plus 120 plus 90 and get 258. But you see, that's only the area for this piece, and this piece. I need to double that to figure out the area of all of it. And I end up with 516. And I'm going to go ahead and look at my label, which is meters square. Okay. So kind of looking down at the bottom, you can kind of notice that there's a pattern. Here it is. And what pattern do you notice when finding the total surface area of the rectangular prism? You could have doubled this here, you could have doubled this here, and doubled this here, and then added them all together. But what you're noticing the pattern is you have to find the area of one and double it, right? So we have to double, I would say, double the area of each surface. And that's not completely accurate, but double the area of this for this, double the area of this for this, and that for that. Okay. All right, let's continue on here. If the net above was a triangular prism, then what would change about the process? You know, if it was a triangular prism, all right, we'd just have a triangular base, and we would use this formula. Area is 1/2 the base times the height, right? That would be the biggest difference there. Okay, so that's a good start. Let's flip it over to the back and see what we can get into some different nets. Okay. Okay, so the next one up, it says find the surface area of the nets below. Use the tables to help you. Okay, no problem. So some like to set it up this way. And again, if you do a little bit different, I'm fine with that. Shape 1, I'm going to say this is shape 1. So it's 18 and what? Well, when I look at this, you know, and this is sometimes difficult, right? When we look at this, we're looking for something here. So we have to be careful, all right? This looks to be some type of equilateral triangle. So you can't kind of look and say, hey, this equal this. Well, when this folds up, it's going to be the same length as that. So the first one, all right, and we know this is a rectangle. It's going to be 18 times 8. That's going to get us that. And I'm going to do it a little bit differently. I'm going to double it this time to see if you like it this way. So 18 times 8 is 144, times 2 is 288. So that actually took care of these two pieces. Now, what I'm going to do, and actually, I don't want to double that. Actually, these all three are equal. So I made a mistake. I'm going to go back and multiply that by 3. And now I'm going to use my calculator because I can't do that mentally. So it's 18 times 8 times 3. And we end up with 432. 432, right? And then what we're going to do is find the area of the triangles, and I'll double that. Formula I'm going to use is area is equal to 1/2 the base times the height, 1/2 times the base. Well, the base is 8 times the height of the vertical is 7, and there's 2 of them, and I'm going to double that, right? And when I double that, you know, 8 times 7 is 56. Half of 56 is 28 times 2 is back to 56. We really don't have a third shape. And when I add these two together, I end up with 488 centimeters square. So in this case, I doubled it on the front end and I tripled it because there was 3 of them there, right? So that's just another way to do it. And I actually prefer that way a little bit better. So, but that's up to you. You know, do what works for you. I have no problem with that. I certainly don't. Okay. All right. Let's continue on. Next one up will be, looks like to be a rectangular pyramid. We have one base. We have to be careful now. These are different. So it looks like this and this are congruent. This and this are congruent. So shape 1, let's take care of our base, is going to be base times height, which is going to be what? 4 times 6 is 24. I'll label it at the end. Shape 2 is this. So it's going to be 1/2 the base times the height, which is 1/2 times the base. The base, I'm going to transpose that 6 over times the height of 6. I'm going to multiply that by 2. And when I do all of that, I end up with 36 inches square. Now, that took care of this, that took care of this, and this. Now I need these two. Well, the base is 4, and it's a triangle. So it's 4 times, and I apologize, I forgot to put my 1/2 down. I'm getting a little out of control here. 1/2 times the base of 4 times the height of 7, and there's 2 of them, so let's double that. And that ends up being 28. And when we add all 3 of these together, I'm just going to grab my calculator, and 24 plus 36 plus 28, I end up with 88 inches square. So I've shown you a couple different ways, and again, I prefer that. Let's slide down here. We're going to work backwards now. They give us a net of a cube, right? And our cube, we know, is 150 inches square. I also know that all sides of a cube these are all equal. So if I find one, I find all the sides, and they want a side length of all this. So what I would do is kind of work backwards here. I would take my 150 square inches and I would divide it by 6 because there's 6 cubes, right? And 150 divided by 6 is actually 25. Now, I'm going to rewrite that there. That means the area of each of these is 25 inches square. Okay? So we continue on. Okay? Now, when I look at this, I know that I got the area by base times height on this rectangle, or in this case, a square. So I would take that, all right, and ask myself, what number, 25 divided by what number, all right, or what number times what number gives us 25? Or, you could take the square root of it, all right? But I would know that, if I found that out, what would get times what? Because it has to be the same number. It's equal. Well, 25 divided by 5 is 5. So the side length of each of those is 5 inches. 5, 5, 5, 5, 5, 5, 5, 5, and so on down the line. Okay. All right. So now we have another triangular pyramid. Let's look at it. Find the surface area of the triangular pyramid. Well, it looks like this base is different, but these three are equal. So I'm going to start with the base. And my base is going to be 1/2 times 10 times 8.6. Okay. And I'm going to go ahead and punch that in. And 0.5 times 10 times 8.6, I get 43. Okay. So that takes care of this. So now let's take care of our triangle. So, well, what do I know? All right. Well, I know that this is 10, 10, 10. All right. And this is 10, 10, 10. Well, actually, I really could have just taken this 43 and multiplied it by what? 4. It looks like they're all equal. It's an equilateral triangle. So I kind of caught myself there. So I'm just going to multiply that by 4 times 4. It's a good pickup on my case, right? And I get 172 meters square. So I found the area of 1, and then I just multiplied it by 4 because there's 4 there. Okay. All right, guys. Well, that's a good lesson. We're going to work on this again. I want to spend 2 days on surface area of nets. So we'll hit this on Thursday as well. Have a good day.